This is a video on polynomial division, which is used to reduce the power of a polynomial being a power typically greater than the power of 2, because it will allow you to be able to factor and break that polynomial down to its basic roots. It is often used in calculus and ordinary equations beyond 1050 mathematics, which is typically where this is taught. As an example of any question that might be given, dividing a polynomial, this is degree 3, and dividing it by another polynomial of lesser degree, such as the following. So another way to rewrite that, and the more common way that you'll see it, is in the form of a ratio or a fraction. It is important to note that the power in the bottom must be less than the power on the top in order for this to work. So it's good practice to rewrite the equation as the following. It gives a good baseline. As you would with typical normal division, you would just take whatever number you have here, and you take the ones, you take the highest place, be it thousands, millions, whatever, and you divide by that many. However, in this case, since there are x's, we need to use another polynomial. So we take a look at this. We want the 2 to be eliminated, so we can imagine that we want a 2 up here, and we have an x cubed, so we want to have an x squared. So we'd expect something like this, which then we would distribute to both terms, being x and the plus 2. So we'll get the 2x cubed, and we'll get 4x squared. And then we will negate it like you typically would in normal long division. However, it's an important thing to state here, because if you forget to distribute this negative all the way through, you get different answers that will be wrong, and it's a step that a lot of people struggle with and will end up getting the question wrong. So we'll go ahead and subtract everything through. This will go to 0, this will go to -7 from the distributed negative. We see that here. This 0 here is irrelevant. It's not necessary. It'll disappear off the next slide, but I'll continue to have it show up and disappear later. As you would, typically we'll carry down this 4x and the 5 all the way through. So now we'll look from this line. We have a -7, so we'll have a -7 up here because we're going to multiply this by -7 and an x squared. So if we do -7x, that will give us our -7x squared and -14x. And we see this here. Again, we'll negate it, put the negative here, and this will make all this positive and make this 0, and then this will go to positive 18x plus 5, because when you pull down the 5, we have our 0 here because that cancels out. We then can look at this easy. We'll just say plug in an 18. We'll get 18x plus 5. Distribute the 18 again. Get 36. Distribute. And cancel, which will give us -31. Now, since we have a remainder, we know x plus 2 is not a root, meaning whatever polynomial this looks like, it will not cross at x equals -2. But it does allow us to reduce this to a different form with a remainder, which is -31. We then can rewrite this to be 2x squared minus 7x minus 18, which is what we found here. And this -31 is the remainder. It will go here, divided by our x plus 2, and that will be our final answer. Some really good resources are OpenStax, which is what we use to teach pre-calculus. This is a particular chapter that we'll cover on dividing polynomials. LibreText is also an excellent textbook. This particular chapter will go over synthetic division, which is another means that you can go through and do this. It's the same process, you just kind of write it a little differently. And then Math is Fun is another great resource.